I'd like to thank everybody for the opportunity I have to present and record this presentation. I'm very proud of my research, and I'm very grateful for all the contributing authors as listed below who helped to gather this research, to gather the data, and to gather the placentas, and followed the protocol and got me the data I needed to present and bring this presentation together. Today, I will be speaking on fetal-maternal barrier integrity as a window of diagnostic opportunity. So as we know, fetal demise and intrauterine growth restriction are devastating conditions for families and for society, and they are both associated with an increase in healthcare costs. Non-invasive diagnosis of fetal condition is critical for the prevention and the treatment of both of these conditions. The presence of fetal markers in maternal circulation, such as cell-free DNA, exosomes of fetal origin, and specific microRNAs have recently been used for diagnosis. The barrier between the fetus and the mother, as we currently know it, is a very dynamic barrier that includes fetal endothelium, immunological cells, and fetal syncytiotrophoblasts. And all these cells have different roles in the contribution of that barrier. Placental hypoxia has been linked to both FID and IUGR, and the aim of this study was basically to determine the fetal placental leakage as a function of placental hypoxia, an ex vivo model of a human placental perfusion. So as far as our materials and methods go, we took 8 placentas that were collected from cesarean deliveries according to the approved IRB protocol. And isolated placental cotyledon was then cannulated within 5 to 7 minutes after delivery. The perfused placenta was exposed to ex vivo oxygen conditions and hypoxic conditions for 30 minutes at each of these conditions. Then fluorescein isothiocyanate conjugated dextran was added to the fetal buffer at the working concentration of 200 micrograms per milliliter. Perfusion was performed during those 120 minutes. The data was collected on the maternal and fetal exposed pressures, as well as the leakage of FITC dextran from fetal to maternal circulations. Here's the results. In the condition of maternal hypoxia, the leakage of FITC dextran markedly increased. The maximal increase took place within the first 10 minutes, mimicking acute hypoxia. After the first 10 minutes, the velocity of increase of fetal leakage into maternal circulation then stabilized and plateaued. As described in the previous slide, here is the graph. The graph demonstrates that in the first 10 minutes of hypoxic conditions showed the largest increase of fetal to maternal leakage of dextran. This thus supporting the theory that hypoxic condition increases fetal maternal leakage. So in the graph below, you can see that there's two parts of the graph. The first 60 minutes was where the fetus, or the placenta of the fetus was exposed to normal oxygen tensions, and in the second part of the graph, the placenta was then exposed to hypoxic conditions. And then on the y-axis, we see the ratio of FITC dextran in maternal perfusate and FITC dextran in fetal perfusate. And then on the x-axis is a function of time. And as we can see at the 60-minute mark, when hypoxic conditions were introduced, we see a peak in the fetal maternal concentrations of FITC dextran. And then it decreases and then plateaus. So as far as the discussion and conclusion of this research, this is a very small step in what we will be having going on in our research department as far as fetal placental leakage. But what we confirmed is that the permeability of the placental barrier is a function of the acute and chronic hypoxic conditions. We see that under acute conditions there is a great increase in fetal maternal leakage. Continuous monitoring of fetal markers in maternal circulation might represent the diagnostic window for differential diagnosis between acute and chronic hypoxia. We may be able to use future markers of molecules and chemicals that are found in exosomes between fetal maternal leakage to be able to diagnose acute versus chronic hypoxic conditions. Our data is in agreement with the published data regarding increased fraction of fetal exosomes in maternal circulation in women with preeclampsia, another life-threatening condition associated with placental hypoxia. So that's the conclusion of my research. I'm very grateful that our data correlated with current data as far as we know that hypoxic conditions, and conditions that affect the fetal maternal circulation, such as preeclampsia, do alter the leakage of fetal exosomes into maternal circulation and fetal circulation. And we hope to further this research into possibly coming up with future diagnostic studies in the diagnosis and prevention of preeclampsia and other conditions which may affect IUGR or fetal intrauterine demise. So thank you for listening, and that is the end of my presentation.